Afternoon students, today we shall be discussing undecidability, which has been already discussed in halting problem, and the definitions and all the examples we have already discussed. But to clarify it again, we shall be taking it as a revision. So whenever we are talking about undecidability, we have to remember two languages. We have to firstly we have to understand clearly. One is recursive language, another is recursively enumerable language. So here two languages has been given. So from the beginning we can see what is recursive language. Whenever these two names are there, it is always associated with Turing machine. Okay, so any language having strings, suppose language L is having strings, and once it is accepted by a Turing machine, then a language having strings, once it is accepted by a Turing machine, then it falls in L. If it is rejected by a Turing machine, then it is not in L. So in that way we can say that languages having strings accepted and this is rejected by Turing machine. There are two possibilities. If it is accepted, then omega, this is W means omega, is in L and it will halt. If it is not in L, it will also halt, but it will get rejected. So into both the cases, the Turing machine will halt. That means it will terminate and it will stop. Okay. For recursive languages, this is the condition. That means in brief we can say the Turing machine will either give accept and it will accept and halt, and another time it will reject and halt. Okay, if it accepts the language, then the string falls in the language or it belongs to the language, and if it rejects and halt, then the string does not belong to the language L. Okay, this is omega not in L or does not belong in L. In simple term, we have tried to explain in these steps. This is recursive language. Coming to recursively enumerable language, this is also similar to recursive language only, but there is one condition, that once it will accept and once it will reject. But in case of rejection, the Turing machine may halt or may not halt. Okay, that is how we have written language having strings accepted or rejected by Turing machine. But the Turing machine does not always halt, because when it will accept, it will halt, but it will reject and halt. Another case, it may not always halt. Then in that case, how we will write it? Reject and halt, omega not in L, reject and goes on loop, omega not in L. In both cases the string is not in the language L, but once it may halt or it may not halt. That is undecidable. We cannot say whether the string will always the string when it passes through the Turing machine will always halt. Okay, that is recursively enumerable language. In that case, we don't know that we cannot say that the Turing machine will always halt. That is the difference. In recursive language, the Turing machine will always halt, but in recursively enumerable language, it will not always halt, which is associated with undecidability. We will come in the next session. We will discuss in the next video.